Welcome back to this video. This video will look at one more example of FLSM, and this time we have a class address 10.0.0.0/8 given to us. We need 5,000 hosts, that's the requirement. So again we have to look at this 2 power table. So as you know, 5,000 exact is not possible, so as we look, 2 to the 12 is 4096 is not enough, it's less than 5,000. So that means we have to go with the next one, that is 2 to the power of 13 will give us 8192 minus 2 equals 819D. Minus 2 how? 1 for network ID, 1 for broadcast ID we lose, but still we get 8190, which is plenty more than 5,000 requirement. So straight away we know 13 how? 32, the magic number 32. Remember this? So we just minus 13 from 32, we get what? 19. This is your new slash value. So it was 8. 8 was given to us. How this 8? Because here, right? This we have 8 network bits. This slash value represents the network bits. So we have 8 network bits under 10. So this was the network. That's why it's 8. All these zeros are the host part. Okay. Now we have changed to 19. That means again this second octet will be converted to network. So 8 plus 8, 16. So now the network is here, and also some more 3 more bits from the third octet. So that means now the network ends here. So only the fourth octet is now available to borrow, and some more on the third octet, but the entire fourth octet is available. So we'll see, I'll show you like this. Okay, 10.0.0.0, right? So I put, let me put 8 ones here under 10. 1, 2, 3, 4, 5, 6, 7, 8. Let me make it smaller. Okay. And I put 8 zeros here, 8 zeros here, and 8 zeros here, right? So this 8 ones is representing this 8. This is a slash value or the network bits. Okay. So right now the subnet mask is, let me write it down, 255, right? Because 255, all these ones we add, we get 255. 128, 64, 32, 16, 8, 4, 2, 1, we get 255. So right now the subnet mask is 255.0, because these are all zeros, right? Dot, again 0.0. This is the subnet mask right now, 255.0.0.0. But we are going to do the math right now. So we already figured out the new slash value, 13, right? So 13 means we are keeping 13 host bits. Okay, we always start from the right. So this entire 8 bits we are keeping. Then here 9, 10, 11, 12, 13. This much we are keeping. The rest of this, that means this 0, all the way until the entire, the second octet, we are converting to network bits. Understand how? This 13 means we are keeping 13 host bits. 8, 9, 10, 11, 12, 13. Okay. The rest, 1, 2, 3 from the third octet, and the entire 8 on the second octet we are converting to the network bits. Now look, this is going to change, right? Because this is no longer 0 here. We have 8 ones here. 1, 2, 3, 4, 5, 6, 7, 8. That means this is now 255. This is now 255. This one we have 8, 9, 10, 11, 12, 13. 3 bits we are converting to network. That means 128 plus the first one, the value is 128, then the second one is 64, the last bit borrowal is 32. So 128 plus 64 is 192 plus 32 is 224. Now this has changed from 0 to 224. Understood how I got 224? This three ones, 128 plus 64 plus 32 will give you 224. These 255 because the entire network bits are taken and all ones equals 255 because 128 plus 64 plus 32 plus 16 plus 8 plus 4 plus 2 plus 1 equals 255. Same here, but here is only 3 bits borrowal. 128 plus 64 plus 32 equals 224. Last octet, we are not converting anything, so the 0 will stay. The new subnet mask is 255.255.224.0. Okay, and the network ID is same what's given to us, so it will be 10.0.0.0. Okay, and the new slash value is slash 19. New slash value is slash 19. Now the block size, right? What's the last bit borrowals value? We are ending here. This is 32. That means 32 is the block size. So our network will end at 10.0.31. 32, we cannot go, we cannot take the entire 32. 32 will start on the next subnet. So minus 1 is 31.255. This is the broadcast address, okay? This is the network ID. Okay, and what's in between will give us this many addresses, 8192. Okay, so for example, this will go 10.0.0.0 until 10.0.0.250, no, 0.255, right? Because we cannot go beyond, I put one extra 0, 255. We cannot go beyond 255, then that means this 0 will become 1. So 10.0.1.0 and that will end at 10.0.1.255. That means we cannot go beyond 255, so this one will become 2. So 10.0.2.0, 10.0.2.255. So now this will start at 3.0, 10.0.3.0, 10.0.3.255. Each of this will give us 256 addresses, right? So here we get 256, here we get 256, here we get 256, here we get 256. So like that, we are going to go all the way to 10 dot, or here I already put 10.0.31.255. That will be the broadcast. That many addresses, right? 4.0, 5.0, 6.0, 7.0, 8.0, 9.0, 10.0, 11.0 until all the way to 31.255 will give us this many addresses, which is plenty more than 5,000 hosts. So we have figured out, we have satisfied the requirement. So this is how you would work out this particular requirement. And if you have any questions on this, please ask. And if you need to see any other specific examples, please let me know. Other than that, we'll see some other interesting uh, examples in the next video. Until then, stay tuned. Thank you and good day. Bye-bye.